Hi, I'm Steve Spencer. I'm a consultant for Vanstone Bailey, so I do .NET stuff and Azure stuff and whatever. And currently working for Deloitte as a technical lead. Everything I talk about, I've blogged at some point on my blog, and if you want to get hold of me, there's my Twitter handle. The first few things I want to go through are the developer slides. So there is a code of conduct. So please be respectful and friendly and whatever. Anybody who's abuses that will be kicked off the system. So just be nice to everyone. We're all doing this for fun and to help you and to give you loads of information. So please be kind. Well, any proceeds from this will go to the National Museum of Computing. So if you'd like to donate, there's a link there. You can donate to them. We've got some sponsors. So if you see anybody from them, speak to them, say thank you. We can't do these events without these people, so we need their support. And just please tweet and say how brilliant this is, and let everybody know that it's going on, so we can get a good community going. Okay, so we'll get started now. So I'm going to talk about my project. I'll introduce you to this device that I've been using. It's called ESP8266 and micropython, and we'll show how I can connect to IoT Hub. We use Azure Functions to pull the data from IoT Hub and Cognitive Services, and there'll be loads of demos on the way. So hopefully you'll find this interesting and enjoyable. So the first thing is I'm not a professional IoTer, so this is something I've been doing in my spare time, something that I've sort of found interesting. And I had a project a few years back, which I used a Raspberry Pi to do this same project. So I thought I'd get the project back out because I already built the hardware for it, and I used it as an opportunity to get myself familiar with Python. I've not used Python before, so I thought this would be a good place to start. Previously, I just used Service Bus to do all the communications, but now IoT Hub's there and available. I thought, what a better way to use this? So get some IoT devices, connect to IoT Hub. And because it's IoT Hub, I might as well use lots of devices. So I'm using 2. And another thing I wanted it to be was serverless. So what the project is basically I press a doorbell. That'll enable a camera app to click a picture on, so I can take my photo. We take that photo, pass it to Cognitive Services to verify it's me. If it sees it's me, then what it'll do is it'll send a message back and allow the door to be opened. I do have a door. It's only little. I've built it myself, so don't laugh at my handiwork, but got it there. And also, I just wanted a couple of extra things just to make this a bit more interesting. I've added a temperature and humidity sensor. So I wanted to basically, one of the devices is going to read that regularly, and then it will send that up to IoT Hub, and that'll get stored in Azure storage. So we could then do some processing on that later if we wanted to. So, oops. So this is sort of the idea. So we've got the doorbell. It's connected to one of these devices. I press the button. It sends a ding dong message to IoT Hub. I've got an Azure function sitting there waiting for messages from IoT Hub. It sees the ding dong messages. It puts it on the service bus, which the camera app is listing on. Camera app then will enable the camera to view a picture. It'll allow you to take a picture, passes that to Cognitive Services. If it finds a match, it will then send an on message to IoT Hub. We've got the second device waiting for on messages. The on message happens. It clicks a solenoid, which then unlocks the door. It then sends a message back, which then goes to Azure function, which sends opened. It goes to the camera app. It turns the camera off, and sends an off message, which then sends the off message back. There's a bit of a delay there, so to give you a chance to open the door, and then it locks the door back up again. So fairly simple, fairly straightforward, and hopefully I can show you how all this works. So first thing is we've got this device called an ESP8266. It's a really cheap device, they're about £5 each. And the nice thing is it's got built-in Wi-Fi. So you don't need to have any additional hardware to do that. The device I've got is actually it's a developer board, and it has a built-in USB adapter, micro USB adapter, so you can use that for power and for communicating with the board. So it's all self-contained and really useful. You can use loads of languages on it. So the device I bought was called a Node MCU device, and that has the ability to program it using Arduino. So I've had to then download MicroPython and burn it onto the device. But it's got a load of GPIO devices, which is general purpose I/O. So there can be inputs and outputs. It also has serial ports on there. And because it's got the USB, it's got this built-in power supply as well. So it's pretty good. So I could run it from like a USB battery if I wanted. So we could have it as a remote device somewhere, as long as we've got within Wi-Fi range. It doesn't need to be plugged into the mains room. So MicroPython is a free download, and it's a lean implementation of and a subset of Python 3, which has been optimized for microcontrollers. So it aims to be compatible with standard Python, and it runs in a small code space and RAM. So that's really good for these devices. And the most important thing for us for communicating is it supports MQTT, which is messaging protocol. So that allows us to send the messages out that we need. So this is the device. So you can see this bit down here is your antenna for your Wi-Fi. We've got a USB port here. We've got a reset button, and then we've got a number of ports. So we've got all these GPIO ports, but some of them you can see can be configured for different things. So we've got a number here which can be set up to be a serial port. We've got various other outputs as well, analog digital converter port as well, and you've got various pin outs for power and stuff. So you've got enough bits on there to be able to set up quite a few things. You see on Amazon recently, you can buy 3 of these devices, Maker Hawk ones, which is what I bought at $15.99 for 3, which is pretty good. There are some cheaper ones out there. I've not used them. I saw there were some slightly smaller ones which were cheaper, and you can get them for about I think you can get them for about £2.50 each now if you buy them in 10 sort of thing. So if you want a lot of them, there are options out there. So let's do a quick demo. So first thing is, you can see I've got my device. This is one I'm going to be using for my demos. So all I've done is I've plugged it into a board. I've got the temperature and humidity sensor here. I've got a button here, and I've just got an LED so you can see what's going on. But there's also a LED down here as well, which you'll see it'll be flashing on and off. Then this is the other board, and this one's just got a relay on here. So this is the one that's got the power going to the door. So first thing we can do is we can go and I'm using the Arduino. It's got a serial monitor port, so it's just got a COM port. Because it's plugged in, it thinks it's a serial port, so fairly easy. So if I go in here and just press enter, it comes back with the Python prompt, and here we can start writing Python if we want. So let me just do a bit of. Oops. So we've got some libraries on there that allows us to do the communicating fairly simply. So I can't talk and type at the moment because it's got to think about what I'm typing. So what I'm doing here is setting up pin 4 to be an out pin. So which will be it's effectively the port that this LED is connected to. And what we can do now is I can just say p0.on. Oops, the type in there. What have I done wrong? see the LEDs come on. So similarly, if I change that to off, I can just turn it on. So we can write our Python there. It's a good way of just proving that we've got that connectivity to the board, but it's not very practical in this emulator really to do it. But it's really useful because you need to set this up in the right way for your serial port, however it's come up. So it does take might take a bit of messing around here to set these up to get this working. So once you've got this working, you should be able to press enter in there, get the prompt up, and then start. You could write this bit of code, and it should be able to work fairly easily. We can also, so that was a showing you some output. So let me look at the sensor now that we've got on there. So this temperature humidity sensor we have here, and that's using a package called DHT. So we can do so this one's sitting on pin 16, and then what we can do is tell the sensor that we want to read what's on it, and then we can go and retrieve the data. So if we do read the humidity, oops, I spelled that wrong. So it's got a humidity of 67, and then we can do the same, and then we can do temperature 21. So what we can do is we can write a little message loop in our code, which will regularly just read that data. We'll call the measure, and then we'll call humidity and or temperature, and extract that data. So you can do that. So there's some output there and some input. Again, it's not that useful on its own, because I can't just keep writing this every time I use it. So we need to start writing a bit of code. So there is a tool that you can download called AMPI, and what this allows you to do is to interrogate the device a bit more. So we've got this thing called AMPI, which you download. I put a delay in of half a second, so that's basically just what. Without this, sometimes you get errors back because it's happened too fast. Depends on your devices and on your serial port. Tell it which COM port and the baud rate, and what I'm doing is I'm going to tell it to do a directory list of the device, so you can see what files are on. Oh, yeah, I need to get rid of the connection to the device. It won't let me access whilst it's busy, and you can see that it's listed the files that are on there. So we've got a couple of files on there which are needed for later, for when we talk to IoT Hub. We've got the config file. This is the code, some of the code that we're using and whatever. So what we can do is we can change the command. So what I want to do is let's get one of the files off there. And you can see what it's done is it's echoed the file to the terminal, so we can see what's in there. If you wanted to pipe that into, if you wanted to like pass that into, that would put it onto this hard drive. But I'm not going to do that. But you can also do. So I've got this file called flash LED. So again, I'm importing. So this is what I showed you previously. And then you see I've got the LED on and LED off, and I'm just doing it in a loop, and it sleeps for a bit. So we're going to flash 10 times. It'll wait half a second between each one. So what I want to do is upload this file into the device and run it. So what we can do there is we can do so that's saying get the file flash LED from this folder, get on the device called flash LED. You can see it's not in there at the moment. So if we do the LS again, we should see that it's appeared. But similarly, we can do and it's gone again. So I've added it and removed it. So you can copy files from your device. We can also do a similar thing, and instead of uploading it, I just want to tell it to run. So what this will do is then upload that file temporarily, run it, and then it will stop. So if we click that, we should see this LED flashing on and off. So you should do it 10 times. There we are. What we can also do is if we want to do we can change this to be main. What that will do is when I reset the board, it will automatically run that file then. So that's uploaded. So if I now reset, you should see from board. See, it's now started flashing. It's just loaded that file up. So this will stop after 10 flashes, and then there we are. And we can go back and do remove that. So if I do that, that's again, it should have disappeared. So if I reset this board, you see this time it hasn't started back up. So yeah, that's it. So go back to my slides. Where's where they go? So I can't get Teams under my. So let's go back to the project. So we've got this ESP8266 with a doorbell. We've got a door which I've built. It's a little thing. It's got a little solenoid door bolt on there. So when we put a current on it, it pulls the bolt back and unlocks the door. I've got another ESP8266 with a relay on, and when that relay triggers, it opens a circuit for the solenoid to pull the door back. And you've seen I've got this LED status thing, and also the temperature and humidity sensor on there. So this is what the solenoid looks like. You see the two blue wires. When the current's across those, that pulls that bolt back and allows the door to be opened. I bought this kit a while back. I had to check. I think it's a slightly updated version to the one I bought, but it's £30 on Amazon. It's got 37 different sensors in there, all doing lots of different things. I've just pulled the temperature, humidity, the relay, and the button out there, so you can see those were on my board. There's loads of things in there. It's got buzzers and joysticks and sonic sensors and loads of water sensors. There's loads of stuff in there. It's really, really good. If you want to play around with stuff and have a thing, they're all pre-built, and the ones I've picked have all had drivers for them in Python, so that's pretty good. But I've only used a few, so then you've seen this already. So when I've plugged them all together. That's what we've got. So that's a relay. That's a button. And that's your temperature sensor. So the next part is IoT Hub. So this is a IoT Hub's a cloud-based solution for in the back end to basically allows you to connect devices together. It allows you to have bi-directional communication between IoT devices and Azure. So it's really useful. It's not just reading stuff from the device. You can send data down to them as well. So you can do that using cloud to device and device to cloud messaging. And each device has to authenticate with IoT Hub, so you've got that extra layer of security in there. And as I said, it supports MQTT, which is really useful because Python supports MQTT, which allows us to talk together and connect everything up. And then we've got the next part we'll talk about is Azure Functions. So I don't know if you've used these, but it's a serverless way to run code. You basically write some code, upload it to an Azure function, which runs in an app service. So you've got that sort of configuration, and it has a really useful set of bindings. So they're basic attributes in your code that simplifies connectivity. So you don't have to write a lot of code to do quite a lot of things. So I'm using 3 different bindings. One's a trigger binding, so an IoT trigger binding. It allows me to wait and listen for messages on a specific endpoint in IoT Hub. I'm also using a service bus output binding, which allows me to put a message on the service bus. I'm using an Azure storage return binding, so that allows me to store data in Azure storage really easy. So when you see the code for this, you'll see what I mean about the simplicity this gives. So these triggers, these bindings make life so much easier. You can do quite a lot without really having to write much code, which is, I'm always a fan of that. So we've then got cognitive services. So cognitive services is basically an AI API for developers who don't have any machine learning experience. So Microsoft have built on their expertise and other people's expertise to build a whole set of libraries that we can use to do things. So they've got a decision API, a vision API, speech, language, and web search. So you can pick through those. If you go on the website, there's a whole load of, some of them you can sample, so you can run it on the website and see what happens. So what we're looking at is we're going to use, in the vision API, there's a face API. So what it allows you to do is face detection. It does face verification. So once it's found a face, it will then verify whether we think it's somebody we know. And you can also look at it tries to sort of evaluate what your emotions are when it captures that picture. So you've got a number of things you can look at, and it works in a two-stage approach really. So you have to train the model up. So you have to basically go into the API and say, here's a set of pictures of Steve. Use those to train the API, so that when we have another picture, a different picture of Steve, which is not one that we've trained on, it will try and work out whether it's the same person. What that does is when it verifies, it will come back with a confidence score of how likely that picture is to be me. You do have to be careful because I have had a few false positives. So when I first set this up, I'd got myself in there, some pictures of me. I got some pictures of my wife in there as well, and it worked really well between us. It most of the time it picked me or picked my wife. If it didn't, sometimes it depends on how good the picture is and the angle, and I've got glasses, so reflection of glasses, that sort of thing. But generally it picked us out. So then I thought, right, what we'll do is we'll try it with my daughter, see if so in theory she should come along, get a picture taken, and the door wouldn't open. She'd come along, it took a picture, and the door opened, and we were like, oh, I wonder what that is. And it thought it should look like my wife, which is, I guess, not surprising really. But and if we'd have looked at the confidence score, it was probably a lower score than it would have been if my wife was there. But that can lead to false positives. So what I ended up doing was took a picture of my daughter, retrained it with the 3 of us, and the next time it came in, it did recognize her, but it didn't recognize her as my wife. So just got to be careful of that. when you're training these things up. So I guess if you're a twin, there's a bit of an issue there, I suppose. So what we'll do now is we'll go through a demo and show you all this connected together. I'll go through each bit individually, and then we'll get the door opened. Oops. So let me just set this up to do. So I've got a so what this is going to do now is it's going to load the code. You see, I've got some various things in there that tell me I better connect this one up as well. So you might hear a bit of a that's not looking too good there. Let's let that come back. You know what they say, never work with children, animals, or electronic devices, I guess. That didn't sound good because it should have made a bit of a noise then when I turned that on, because it's got this relay connected to it. So let me just try that again. It was working before I started. There we are. I don't know if you heard that. Basically, when this starts, I flash the LED 3 times, and because the LED is connected to the relay, it clicks the door lock. So it's a good way of knowing. So you should see these. Right, there we are. So these 2 LEDs in here flashing regularly. That one is. This is the one. There we are. So in the code, let me bring that up. So we have this code. So basically, what we have is I just have a worker thread running, and every 5 seconds it runs through and it does that sensor measure. It then gets a temperature and humidity and packages up as a message to send to IoT Hub. So I've got my IoT device there, and then it calls this MQTT. It says where it should be going on IoT Hub and sends that out, and it flashes the LED to tell me it's doing it. So that's what that LED flash is all about. And then it sits there and it's waiting. So it's waiting for messages to arrive.
You have one question about where the camera is plugged in.
The what? The camera?
Yeah.
That's on the camera's on my laptop. So the app that we have running, the camera app, is a device that runs on my on the laptop. So that's yeah, that's a standalone app that I'm running. Yeah, I haven't tried connecting the camera up to. I don't think it's powerful enough to do the cameras, to be honest. But oops, that's my cursor now. There we are. So we've have to connect up to the IoT Hub. So what we can do now is if I look at where's my browser gone? So in the browser I've gone to the Azure portal, and we've got this thing called IoT Hub, which I've provisioned up already, and in here it should be coming through with devices. So these are all the devices that I've got. We can also do this in Visual Studio Code. So there's a plugin that you can put in there, and you can see that I've got all all the devices there. This one's showing as online. So what we can do with this is I can send a cloud to device message to that. So that should say, oops, I need to show my screen. Don't need this. So that should. It's worked well. There we are. So it took a while to come through there. So the lights come on. And if I do go back in here and do it off, that should go off. So this is, I mean, this is basically taking it from my desktop, my laptop, pushing the message onto the IoT hub, and then waiting for the device to pick it up. So this seems to be slow this way around. We should be able to do the same thing in here, over there as well. Message device, and then I can do on, and then send message. That's come on. So that was a lot quicker that way around. So what we're doing here is because the device is sitting there listening to IoT hub, we're basically sending messages from the cloud into the device. So that's really easy to do that. We can also go into here and do start monitoring. So what this will do is it's listening to data coming in. So what we'll see is when this LED flashes on here, it should. There we are. So you can see it's pushing through the temperature and the humidity. So the temperature 21, humidity 64. So it's every 5 seconds it's pushing that through. So if I try and make this a bit warmer, let me just pick this up and blow it. So what we should see in a minute is these figures, these numbers going up, or at least the humidity one anyway. There we are, humidity's gone up to 95 now. So every 5 seconds you can see the temperature hasn't changed much, but the humidity's gone up. So it's pulling that data through from IoT hub. So let me, how do I stop? Right, so let's bring this code back up. So what we've got to, we'll just go back to the code. So where should we start? Let's start with connecting through to the MQTT. So as I mentioned that there were some certificates on the device, we need that for the SSL. So we put that certificate in, we configure up, we give it the username. So this is basically standard thing. So the client ID is we'll get that out of the Azure portal. We'll get a shared access token from that data, and we'll call MQTT client. So that's part of the micropython stuff. We tell it where to go. We give it the password and username, and we set a callback. So we've got this callback called light LED. And what this does is what I've got here is this. You remember I said it sends an unlock message back. So this is basically saying that the door's unlocked now. So when the light comes on, we send that unlocked message back so that the camera app can then turn its camera off and also then unlock the door or relock the door after say 5 seconds. We publish that. And then we're going to subscribe to messages that are coming to this device, and then we flash the LED. 4 times. So when it started up, you saw that LED flash, and then you may or may not have heard the relay clicking. So yeah, so that I've shown you all this already. So the next thing I want to look at is the code for this. So so if we go to the Azure function, so we have a number of things. So we've got a return variable. So this is saying write to that table on this connection string whatever's returned. So as you can see down here, we're setting up, we've got a class called that represents the table entity in Azure storage. We populate that data and we return it. And returning that data saves whatever's in there to that table. And I'm returning null when I don't want to save anything. So sometimes we don't want, the message is not a temperature humidity message. It's going to be one of these other two. So in those scenarios, I'm returning null, so that will not return, not save anything. So all the code I've written to save to Azure storage is that line there, and that line and those lines there. So really simple. I've also got this input here, which is got the input binding. So it's the IoT hub trigger. And so it's saying look at these, look on here for messages for me, and anything that comes in. Every time I get a message, this function then gets called with the data in that message. So you can see I'm getting the data out, we're processing it, and it comes back as a dictionary of strings. So I can then look at the pull the message out and then look at what each message is. So we've got those different messages come through, and then the final bit is we have this this service bus binding. So we've got an out parameter. So what that means is if I assign some data to this, it will put it onto this service bus topic. So it's a topic, and this is the topic name. So what we look at is if we look for queue message in the code, you can see that I've got it starts off with null. So if there's no value in it, it doesn't put anything on. But if I put data in, it puts that message on the queue. So you'll see that we get a ding dong message in. So if you remember the picture that I had, if you can see this, you can see this is sending a ding dong message to the hub. The Azure function is receiving ding dong and then pushing it onto the service bus, and similarly, it's receiving unlocked and pushing opened onto the service bus. So that's what this code is doing. It's receiving ding dong and pushing ding dong on the service bus, and it's receiving unlocked and putting opened on the service bus. So the code that we've needed to do a message on the service bus is this bit here, and then we've got 1, 2, 3 lines of code to put messages on. So this whole function will receive messages on IoT Hub. It will, if it's a temperature, humidity, it pushes it out and saves it into Azure storage. If it's another message, it pushes it onto service bus. And it's all done in what we got, 30 odd lines of code. So it's pretty good, pretty efficient, and it just sits there running. If we now look at the cognitive services part. So first thing, so basically this app has 2 parts to it. The first part is training. So I've trained this up with 2 people. So I've put 5 images of me in, and I was testing this out when I was at my mum and dad's with my nephew. So I trained it up with him so he could at least open the door. So I've put two lots of messages in. We have this face client, which basically we set up, and there's a whole set of code. I'm not which basically just sets up the face client with the details that we've got. We have to give it a person group name. So this is basically saying this is a set of people that I want you to identify. And we're going through that. And I'm just seeing, are there anybody already in this list? So if I've trained it already, I want to wipe that out and retrain it with a different set. So it's just clearing that out. And then we're going to create that group again with the recognition model, person group, and then we're going to go through each of those people in this dictionary and pass the details of the image through for each one. So you can see the image, we're opening it, and we're adding it to the group. When we've done that for all the pictures, for all the users, we're going to train it. And then whilst training is happening, so it takes a while to finish off. So you just keep go around the loop and wait for it to finish. And once it's done, you can then use that to detect the face. So how do you detect face? So what we're going to do here is we've got the code that receives a message on Service Bus. What it does is when it receives that message, it enables a camera, so it displays the picture live camera feed on the screen, and you press the capture button, which is what this is. It connects up to that same face client as before. It grabs the image, and then it uses the detect with stream async method on the face API, and it has a list of faces that it detects. So this is the first phase. So you basically go through and say, here's a picture. Give me a list of all the faces that it matches. So it comes back with a list of faces, and what it then does is it goes and calls this identify endpoint, and says, of the faces I found, check in this person group ID, the one that we trained up earlier, do we have any matches? And it comes back with a match. And what I'm doing is basically saying, do we have any matches which has got a confidence of greater than 50%? So I've just put this as an arbitrary value in. What it says is if we're less than that, then we're not who we say we are, and then I'm passing that data back to turn it on, to unlock the door, and then turn it off again. So yeah, so this is sending the device to device that one. So what I didn't say is when we press the button on the device the first time, it puts an LED on. I did that just to show that what happens. So I'm telling it to turn that LED off and turn the other one on, which then unlocks the door. And then later on we'll get that message back. So what we'll do is let's run this up, and let's hope everything is working. Let's bring my camera back up so we can see what's happening there. So you see the two LEDs are still flashing. The function app is starting. Oops, didn't want to do that. And then my really impressive camera app is there. So I've got a button for teach. So that was that button you saw. So I've already got the images. I can do some testing. We should have a capture button. So everything's running now. Yeah, that's running. So what we should see is this receiving messages. So it's now receiving messages. Here we are. Look, so it's receiving the temperature and humidity data that we saw. So every time that's been running, messages have been put on that. So what we can do is if we go into this Azure storage and just refresh this, so we should see now all the data that's been put in. So you can see this has all been done today. So we've got those various temperature and humidity things. So we ought to see there's a lot that's been running for a while now. So it's still, so you see everything's in there, it's been running, and all that bit of code that we had was fairly straightforward. So let's try this out. So if I press my button, is that running? Didn't work, did it? There we are. So that button LED has come on, tell me that the button's been pressed, and you should see this camera should come on. Come on. This is doing well today. Let's just reset this and run it again. So let's just start. No, wait for this LED to flash. So that should be flashing now. There we are. So that's worked then. So let's try that again. LEDs come on. We should have seen that pull. Doesn't seem to want to work today. This is annoying. Let me just try running this again. Doesn't matter how many times you run this in practice, that it all works beforehand. When you're doing it live, something always goes wrong. Hey, that's not bringing the camera up. Might have to try that again. Anyway, I don't know what to do now. This camera's not coming up, which is really annoying. I'll try one more. I've got a number of cameras on here, so maybe one of them with Teams is interfering. I don't know. So what we would have seen, hopefully we should have seen, is the door open when we saw my face, which is, you have to believe me, it works, but unfortunately I can't show you today. So I showed you the ESP8266 for MicroPython. We connect it to IoT Hub. I showed you how you could send messages directly to the device from IoT Hub and from Visual Studio Code. Showed you how simple the code was with Azure Functions with bindings, and the face recognition should have worked, but unfortunately didn't. So I'm sorry about that. And that's it. So if you have any questions, you can put them in Discord. Nigel, are there any other questions on there?
Yes, there's just one. It says, okay, I see the images from the desktop machine and not from the actual ESP. Maybe try an ESP32 cam. You will have a camera on the device as well as.
Oh, okay.
As well. Yeah. Okay.
Cool. Yeah. Thank you for that. I'll look into that one. I think the reason I put it on the app was more about running cognitive services. So I was running that directly off the camera app rather than on the device. I guess we can look at how we can cook, because there is a REST API, I think, for that API as well. So we could look into doing it that way and seeing how we can get the image from the device up onto cognitive services. That would be an interesting challenge. I think I'll have to try and find some time to look at that.
You have one more message from Rob Mills saying, if you turn on the presentation camera in Teams, you should find that your program will pick it up, pick up your webcam. I had the same problem in my session.
Okay. Is my camera not on then? So turn my camera off, maybe. Let me just try that again then. Oh, I can't get me. I'll find which camera it is now. Hey, got a camera. So let's try this. Actually, let me move this camera, because this is what I haven't shown you. Is I've got this door log. Oops, can you see? Really, really good. my handiwork is amazing. Let me just see if I can get this here. Can't get it to stay. Can we see the lock? There we are. So let's try this. There's my capture button gone. Capture the image. Oh, doesn't want to help me today, does it? Oh,
yes!
Yay! I've got a door. And then it's locked again and I can't open it. Way! Thank you, Rob. Appreciate that. Hey, and that's it. On that note, thank you all for listening. I'll hang around in Discord for a little bit. Thank you, Nigel, for supporting. And I think that's it. So we can end that now, I think.